2002 XV93 is only about 250 kilometers wide. Not a dwarf planet, not a frozen giant, but a tiny dark body beyond Pluto that may have briefly held a real atmosphere. That is the whole mystery. A world this small should be stripped down to almost nothing by now. Its gravity is weak, its sunlight is feeble, its chemistry should be sleepy, almost dead. And yet, astronomers caught signs that gas may still gather around it in the dark. This is not just a story about one obscure rock at the edge of the solar system. It is a crime scene. The evidence suggests that some of the coldest, faintest bodies out there may not be inert at all. They may be quiet, intermittent worlds, switching between silence and breath. Personally, I love that idea because it makes the outer solar system feel less like a graveyard and more like a room full of sleepers. The key clue came from a stellar occultation. That means 2002 XV93 passed in front of a background star, and astronomers watched the starlight fade. If a body has no atmosphere, the star winks out sharply, like flipping a switch. If it has gas around it, the light dims more gradually, blurred by refraction, like a car headlight sinking into fog instead of disappearing behind a wall. In recent observations reported by teams studying trans-Neptunian occultations, the fading did not behave like bare rock alone. It looked more like a thin layer of gas was bending the starlight. Not a thick sky, not clouds, winds, and sunsets. Something much frailer than Earth's atmosphere. But still, air. Air around something only 250 kilometers across. And that is where the suspects appear. Maybe the signal was noise. Maybe the shape of the object fooled the data. Maybe a ring, dust, or topography distorted the occultation. This is why the case matters. In the outer solar system, evidence is never handed to you cleanly. It arrives like footprints half buried in snow. But the atmospheric explanation refuses to go away. Because 2002 XV93 sits in the deep freeze, where volatile ices can survive for immense spans of time. Nitrogen, methane, maybe carbon monoxide. Substances that would vanish closer to the sun can remain trapped there, frozen into the surface, like breath caught in a winter scarf. Then, under the right geometry and season, a tiny fraction can sublimate. Solid becomes gas. The world exhales. That sounds impossible until you remember Pluto. Pluto's atmosphere is temporary too. As it moves along its 248-year orbit, sunlight changes, surface frosts migrate, and its thin nitrogen atmosphere grows and collapses. Pluto is much larger, of course, about 2,377 kilometers across. 2002 XV93 is a fraction of that size, which is exactly why this case is so unsettling. If Pluto can breathe, fine. If something barely 250 kilometers wide can do it, the threshold we trusted may be wrong. This is the part that stays with me. We like clean categories: planet, moon, comet, dead rock, active world. But nature keeps smearing the labels. A tiny body beyond Pluto may spend most of its existence looking inert, then cross some delicate thermal line and briefly become a place with weather-like behavior. Not whether you could stand in, obviously. More like a film of gas, so thin it would make Earth's upper atmosphere feel crowded. Still, the distinction matters. Because once a body can hold even a transient atmosphere, everything changes. Surface grains can move, frost can migrate, heat is redistributed differently, escape rates matter. Chemistry becomes seasonal instead of frozen in place forever. Think of it less like a dead stone and more like a sealed thermos left in a blizzard, slowly releasing a whisper of vapor each time the lid shifts. So let me ask you this. Do you think the clue around 2002 XV93 is more likely a real atmosphere or a misleading surface effect? I genuinely love your take before we go deeper. To understand why astronomers are taking this seriously, we need to talk about scale. A 250-kilometer object has very little gravity. If you jumped there, you would not fall the way you expect. Gas molecules, especially warmer ones, can reach escape speeds more easily. Over billions of years, that should empty the tank. This is why the outer solar system was supposed to contain many frozen relics, but not many tiny worlds with active envelopes of gas. And yet, distance works like an accomplice. Far from the sun, temperatures are so low that molecules move more slowly. Escape becomes harder. Ices last longer. A tiny body cannot hold a thick atmosphere the way Earth can, but it might hold a vanishingly thin one for a short time, especially if fresh frost is exposed or if the object is nearing a slightly warmer part of its orbit, like steam briefly fogging a bathroom mirror before disappearing again. That possibility matters right now, because occultation science has become much better. More telescopes, faster detectors, tighter predictions, better timing. Tiny dips in starlight that once would have been missed are now measured across multiple observing sites. In the 1988 occultation of Pluto, astronomers used this method to confirm its atmosphere. In 2015, New Horizons transformed our picture of Pluto's haze layers and nitrogen escape. And in the 2020s, the same toolbox has been pushed onto smaller and dimmer targets. So this is the deeper shift. The edge of the solar system is no longer just a catalog of dots. It is becoming a place where we can test behavior. Not just what is there, but what it does when no one is looking. But there is a harder question hiding under all of this. If 2002 XV93 can hold gas, even briefly, how many other so-called dead worlds are doing the same thing? How many tiny Kuiper Belt objects are passing through private seasons we have never noticed? How many are coated in frosts that wake up for a while, then vanish back into the dark? That turns one odd detection into a philosophical problem. We only call these places inert because we almost always catch them at the wrong moment. Imagine flying over a frozen town at midnight and deciding life does not exist there because every window is dark. That may be our mistake with the outer solar system. And there is an even stranger possibility. The atmosphere may not simply be a passive leftover. It could be a clock, a brief repeating signal tied to sunlight, orientation, albedo patches, and buried volatiles. Which means 2002 XV93 might not just be proving that tiny worlds can hold gas, it may be proving that some of them pulse. Oh, that is a very different picture of the deep cold. Once you see it that way, the outer solar system stops being static. It becomes a field of intermittent events, miniature worlds inhaling and exhaling over years, decades, or centuries. Worlds too faint for easy observation, too small for the old categories, and too stubborn to stay simple. Confessionally, this is where the story becomes beautiful to me. The cosmos keeps reserving some of its best surprises for the least glamorous objects. Of course, caution matters. One occultation does not close the case forever. Astronomers will need repeat observations, better shape constraints, and probably more than one event to separate atmosphere from geometry. That is how science earns its confidence, not by one dramatic clue, but by surviving repeated attempts to explain it away. Still, I think the burden has shifted. The question is no longer, could a tiny world that small ever behave like this? The question is, how many have been doing it quietly while we were busy looking for bigger, louder mysteries? If that reversal surprised you as much as it surprised me, that a nearly invisible 250-kilometer object may still breathe in the dark, leave a like. This kind of evidence deserves attention precisely because it is so easy to overlook. We build our picture of the universe around extremes. The biggest black holes, the hottest stars, the brightest explosions. But sometimes, reality slips in through a smaller door. A dim body beyond Pluto. A flicker in a star. A whisper of gas where there should be none.
Ironically, those are the discoveries that feel most human to me, because they remind us how often we confuse invisibility with emptiness.
And maybe that is the payoff here. 2002 XV93 does not just challenge a rule about atmospheric escape, it challenges our instinct to call something dead just because it is quiet. In a solar system full of cold exiles, stillness may be camouflage. Some worlds are not inactive, they are simply slow. So the next time you hear about the frontier beyond Pluto, picture less of a museum and more of a field of sealed rooms, each one cold, dark, and mostly silent, but not necessarily empty. If these hidden worlds fascinate you, subscribe. This channel is for the people who want the universe to feel bigger, stranger, and a little less settled every week.